Hello, my name is Miłosz and I'd like to tell you about some internals of the Angular framework and also how you can benefit from this knowledge. Let me introduce myself quickly first. I'm a software architect at 7N. I've been using Angular for more than 2 years now. I run a programming blog at address codeusestyle.info, and also I love mountain hiking. Before I start, let me just ensure that we are all on the same page regarding the naming. You probably most of you know that, but I will be using these terms a lot, so just to make sure. By AngularJS, I will mean the old 1.x version, and by Angular, I will mean the new 2, 4, 5, 11 version. Okay, now once we've got this clear, let's start. So I can probably assume that most of you here are, or at least some of you here are purely front-end developers, and with that comes the fact that you might not be that familiar with the term compilation. And this joke on the slide, it might not apply to you, it might be reserved more applied to back-end developers. So for you, you can't really say that's not an excuse for you to be slacking off at work, that somebody is compiling. But actually, it might not be entirely true, because if you are using Angular framework, there is some compilation going on, and I will tell you what I mean by that. Okay, but let's have some proper definition of what compilation is. So basically, compilation is about taking source code or written in some programming language and translating it to source code written in some other programming language. And usually the direction is from a more complex programming language to a simpler one. Let's see a couple of examples. So we have, for example, the C++ language, which is compiled to machine code. And machine code is a very simple, very basic language which is understood directly by the computer. So as I said, we are taking a complex programming language and translating it to a simple one. Another example is Java, which is not compiled to machine code. Instead, it's compiled to a language which runs on the Java virtual machine. And finally, we have a completely different kind of compilation, but it still fits the definition of what compilation is. TypeScript can be compiled into JavaScript, and it's still compilation because it's taking source code written in one programming language and translating it to another. And there is even a special... Sure.
Sorry, I think there should be bytecode, not JVM, because JVM is Java Virtual Machine. It's not a programming language. That's bytecode.
But that's an oversimplification, and I agree. Right. So yeah, and there is even a special name for this third example here. This is a compiler that takes that translates. It's called a transpiler. Now let's discuss different kinds of compilation and compare them with something that isn't exactly compilation, interpretation. So let's start with interpretation. This is a method of executing a program, and interpretation is the simplest one. You just take the source code and start executing it line by line. And examples of languages that are interpreted are, for example, PHP or Python. Then we have compilation, and two kinds of it, ahead of time and just in time. Ahead of time compilation is actually the simplest one, because with ahead of time compilation, you take the source code and translate it to something similar during the build process. So basically, you do the compilation before you deliver anything to your client. And this is not the case in just-in-time compilation. Just-in-time compilation is like a mix between ahead-of-time compilation and interpretation. With ahead-of-time compilation, you give your program to the client, and you also give them another program, which is a runtime environment. And this runtime environment starts processing your program. and it compiles the program on the fly and then executes it. So this sounds a bit complex, but it has some benefits. For example, the runtime can optimize execution of the program. Okay, but what does all this have to do to Angular? Because it all sounds very abstract and some theory. There is some compilation happening in Angular. And let's discuss AngularJS first. As you know, in AngularJS, you write templates in HTML, and you can apply some special Angular syntax in these templates. For example, the brackets, which are the Angular expressions. And then Angular takes care of performing the data binding. It watches for changes and it updates the view for you. And the process responsible for that can be looked at as compilation, because there is some translation happening from the HTML template to a in-memory tree representing the document. And then Angular walks down that tree and sets up all the data binding. This used to work in AngularJS and it still works. However, there are some issues with it, unfortunately. So, firstly, the browser inconsistency. Because, I forgot the most important thing on this slide, which is that with AngularJS, it was the browser which was responsible for the compilation. Because browsers have to parse the HTML file anyway. So AngularJS just reuses this mechanism of the browser, and it asks for the DOM model, it gets it from the browser directly, and performs the operations on the DOM model. But as I said, there are some issues with it, and because of the browsers work a bit different, every one of them, the resulting tree of the document might be slightly different in every browser. Which is not good, because when writing an Angular application, you would expect it to behave exactly the same on every application. But there are more issues. For example, browsers are not so good at error handling. As you probably know, HTML is pretty forgiving. So if you, for example, forget to close an HTML tag, then the browser will usually not complain about it. It will just pretend that you closed the tag. And that's it. And when writing a complex application in Angular, you wouldn't like this behavior. You would rather have some detailed error reporting, right? But you couldn't have that in AngularJS. And thirdly, of outsourcing the job of compilation to the browser, you make the browser crucial dependency in the framework, which means that you cannot run your Angular application outside of the browser environment, which is not good, because it prevents you from making some optimizations, like pre-rendering your application on the server side, for example. Good. Now let's go to Angular, and obviously it solved some of the problems mentioned before. And the way it solved it is by taking the responsibility of compilation and building it into the framework. So now Angular no longer relies on the browser to perform the compilation. Instead, Angular has its own compiler, which is a huge complicated piece of software, and its job is to read the template and translate it into the DOM tree and perform the data binding and stuff on the way. What's important to realize here is that now the compiler is part of the bundle you deliver to the client. So every time your client loads a web page in Angular, they load the compiler. And what's more, every time they load the web page, the compiler has to compile all the templates. So it sounds like a bit of overhead, and it also sounds a bit redundant. Why do this all the time? Let's have a look at how big the problem of having the compiler in the bundle is. This is a source map of a Hello World Angular application generated with Angular CLI. It weighs almost 2 megabytes, which is outrageous, I'd say, for a Hello World application. And you can see, maybe you can't see, but I will tell you, that the compiler is over 1 megabyte. So it's more than half of the bundle. So we can see that it contributes to the size of the bundle a lot. Fortunately, there is a solution to that. And it's called ahead-of-time compilation. As we saw in that introduction, ahead of time is a different method from just in time, which means that the default method of compiling in Angular is actually just in time compilation. And this is true because the templates are compiled as late as possible, only when the client requests them. But you can enable ahead of time compilation. So as I said, with the default mode, the client has to download the compiler every time he loads the page, and he also has to compile the whole application. So why not just do it for the client once during the deployment of your application? You can do that with ahead-of-time compilation. And then it will have a lot of benefits. For example, the bundle size will be smaller, and also there will be no process of compilation for the client. Okay, but what is the result of this compilation? Because previously we had the template compiled to an in-memory tree. But now we have to have something more tangible because we have to deliver it to the client. So the templates are actually compiled to TypeScript code. And let's have a look at the result of compilation. And this is actually the result of compilation of this tiny HTML template. We just have a single Angular expression in it, and I highlighted the text so that you can recognize that it's actually the result of compilation of that particular template. Apart from the highlighted text, it's not very readable, and you can also notice that the size of it, which is like big. But yeah, that's the way it is. Now we can see that after performing ahead-of-time compilation, the compiler is no longer part of our bundle, which resulted in a much reduced size. And it's actually, I cheated a bit because I also applied minification here. That's why it's almost 10 times smaller than the original. But 200 kilobytes is, I'd say, acceptable for a Hello World application. There are other benefits of ahead-of-time compilation apart from the smaller bundle size. I already mentioned faster rendering, and that's because the client no longer needs to compile the whole application on every load. We also have fewer HTTP requests, and that's because with the default approach, Angular, the browser, has to request every single HTML template that's in your application, and as we know, they are pretty fragmented, so that's a lot of requests. But with AOT, there are no HTML templates because they are all converted to TypeScript. Then TypeScript is compiled to JavaScript and it's bundled into a single file. So as a result, we have fewer requests. And finally, one more interesting benefit is that if we compile during build time, we get a chance to detect some errors. If you make a typo in the template, then the compilation will break and it will throw an error in your face. And it wouldn't be the case with just-in-time compilation, because with just-in-time compilation, you might not have noticed this error, you might have not tested your application properly, and it would only materialize itself when you deliver the application to the client and he runs into it. So it's much better to be able to detect such an error during compile time, build time. Great. Now a few words about performance of the compiler. Because you already saw that the template generated, the code generated from the template was pretty big, and it's actually after a lot of improvements performed by the Angular team. These are some results from the benchmark, the white paper backing Angular 4, because all these improvements happened in the Angular 4 version. Let's view them on a chart. So these are number of lines. So we have the source template, 245 lines, and after compiling it ahead of time to TypeScript, the resulting file was almost 8,000 lines, which is too much when the increase is huge. But fortunately, after the optimizations applied by the Angular team in Angular 4, the size of the templates was reduced to 1800. And after we compile this, because this is about TypeScript code, and after we compile it to JavaScript, it's only 800, which is still 4 times more than the source, but it's not as bad. Okay, how can you actually enable ahead of time compilation? If you're using Angular CLI, and I have good news for you, you can just add the prod flag, and that's it. It just works, and it will also apply a lot of other optimizations like minifications for you. So that's when you're.
This would actually have a question. If it's the right time, or you want me to ask the question?
Maybe let's take them after the. Thanks. If you're using Webpack version 2, then it's also pretty easy because there is a plugin for it. And there is also another method, the manual way, because I showed you the source code of a compiled template. This compiled template is actually called ngFactory. And I've got this source code by invoking the ngc compiler manually. So you can find ngc compiler in Angular npm package. So you can basically compile these templates manually. But then you also have to modify your main.ts file to enable ahead-of-time compilation. So it's a lot of work. You can find it in Angular documentation, but I don't think it's recommended method. Okay, to sum it up, I will tell you a few words about a topic that is related to ahead-of-time compilation, and it's called tree shaking. Tree shaking is a method of optimizing the process of compilation. And the idea is to not include the code that is not used by your application. It sounds trivial, but it's actually not. And it also can give you a lot of benefits. For example, if you don't use forms, the Angular forms, anywhere in your templates, with AOT plus tree shaking, it can cut out the Angular Forms module from your bundle, and you will save some hundreds of kilobytes. And you can't really do tree shaking with Webpack. At least at the moment I wrote it, you are unable to do that. There is another JavaScript module bundler called Rollup, which is built with optimizations by design, and it's very good at doing tree shaking. So you can have a look into it if you're interested. Great, that's it. I hope you liked it. If there are two things to take away from this presentation, I'd say that one is that compilation is actually responsible for the Angular magic, so the two-way data binding. And the other is that ahead-of-time compilation should actually be enabled in all production applications. Like there are very little reasons not to enable it. There are some cases where it's not possible, but in 99% you should do it. So if you have an Angular application, you should tomorrow, first thing in the morning, enable IoT and done. That's it. Thank you very much. If anyone